afternoon.
Good afternoon. Can you hear me well?
Yes, sir. First of
Okay,
all,
go ahead.
I want to thank you from the bottom of my heart because I'm a scientist in progress and I am a really fan of your work and you as a scientist and a person.
Yeah, thank you very much. I appreciate that.
I have some questions for you, sir. To be honest, the idea is to be so productive on this opportunity.
Well, thank you. And it turns out that there is the plant out there that is part of the endocannabinoid system, and there is the compounds in our brain, in our body, that are, of course, part of our endocannabinoid system. And there are many, many other compounds that our body makes and are closely related. So here we are.
Yes, sir. Thank you so much. Really appreciate it. First question is, how did you find out you wanted to be a scientist?
Sorry, I didn't.
Yeah. How did you discover you wanted to be a scientist?
Well, I wanted to be a scientist when I went to university, found out that this is interesting, attracting, and so I was lucky to have a position in a university and I became a scientist.
So everything started at university?
Well, probably before that, but this is more or less what I had in mind.
Interesting, sir. Second question is, why cannabis? Why? Why cannabis?
Well, cannabis is a natural product. I mean, it is a plant. And as I told you before, I work on natural products, and I was surprised to find out that morphine was isolated from opium 100 years previously, more than that, and cocaine was isolated from coca leaves almost 100 years previously. But cannabis was not so well known. The active compounds or compounds had not been isolated in pure form, and therefore it was worth working on them and see what they do. And of course, it is also a plant that was used widely, not as widely as now, but it was used then in the early 60s. So I thought that's one of the projects I took over when I became an independent scientist.
Thank you, sir. So how did you isolate THC in general? How was the process?
Well, today we're not in the 19th century, but in the 20th century, one has to identify the constituents, not just take a plant and say it's active. One has to identify the constituents. So by using modern methods that were modern at that time, I separated about 10 or 12 compounds, constituents of the plant, and they were purified. It took several years. They were purified, and the active compounds were tested in monkeys by a colleague of mine, and the only one that caused effects typical for cannabis turned out to be THC. So we elucidated the structure of that compound. There were many other compounds like cannabidiol, cannabigerol, cannabichromate. We gave them these names. We gave the name of cannabigerol, gave the name of cannabichromate, and so on. And there were also the acids. In the cannabis plant, there are about 80 or 60 or maybe 100 compounds of the same type, but we isolated only the major ones.
Wow. Yeah, I think there is a new world expecting for new cannabinoid discoveries and industrial and pharmaceutical use. Yes, sir?
Well, as obviously the plant is active, we went ahead to look for their activity, the activity of cannabidiol, and so on. And we did a lot of pharmacology in collaboration. Also, we did some clinical work. For example, with cannabidiol, we went ahead and did a clinical work with colleagues in Brazil. I work a lot with colleagues, and we had earlier seen that cannabidiol works against epilepsy in mice, and this was based on historical work that cannabis works on epilepsy, and it was active in mice. So we had some toxicology done, and then we tested it in humans, and it was active in human patients as well. It took many years to achieve that, but we published it in 1980, which is 40 years ago. But nobody was interested at that time. So it just remained a publication, but then people did become interested in about 5-10 years ago and started using plant that has a lot of cannabidiol, and it turned out that cannabidiol is indeed a very good anti-epileptic compound with no side effect, and today it is an approved drug, and epilepsy is being treated with cannabidiol.
Can we say that epilepsy is the main focus of research now in medical research?
No, we don't do any research on epilepsy.
Oh,
we work on we work on many other things. For example, brain trauma. We have found that cannabinoids are very efficient in brain trauma, and our brain has cannabinoid-like compounds that work on brain trauma, and we have published that. Then we found that cannabinoids in our body, certain cannabinoids that our body makes, your body makes, work against bone destruction, osteoporosis, and we published that as well. And now we're working on compounds that our brain produces that work against addiction. We have found that our brain looks at addiction as a disease, and therefore we went ahead looking for the compounds that are.
Don't worry, sir. If you need to answer the phone, I don't have any problem.
Just a moment.
Yes, sir.
It's okay. Okay.
Okay, sir. So can we say that we are trying to hack or understand the cannabinoid human system?
Yes, of course. I mean, we are not working on the plant anymore. We're working on the human system. And we found that the compounds that your brain, your body makes, my brain, my body makes, work in these effects. And there are cannabinoid-like compounds that work against the brain trauma, work against osteoporosis, work against addictions. Not all of them. We don't know yet everything, but we have published in all these fields, and most definitely against nicotine addiction, for example.
Oh wow. So can we say that we have a long journey to continue doing research?
Well, that is true. As a matter of fact, people at NIH have published and have said that the cannabinoid system seems to be involved in essentially all human diseases. Not as the only one, it works with many other systems, but it is one of the main systems that guard our body from various diseases. So it can open the field for new drugs, I hope. Already cannabidiol is widely used. In the States it's widely used, although it has not been tested. There are clinical work, not ours. People in Germany, it has been shown that cannabidiol is good against schizophrenia, for example, and other diseases. So I expect that we shall see compounds of that type.
Thank you, sir. I imagine myself, or I guess, that cannabis has opened new doors for more natural produce research?
Well, I don't know. Most companies don't work on natural products. There are problems of patents and money and so on. Yes, many of our drugs are based on natural products which have been modified. And like penicillin, you cannot buy penicillin, you can buy a modified penicillin and things of that sort. But many of our drugs are based on natural products and their activity.
Wow, wow. What's the next for cannabis research then?
Well, chances are that, like with most drugs, you see, cannabis, the plant doesn't make the compounds because we are interested in the plant. The plant makes it for itself. So chances are that companies will make changes in the structure of the cannabinoid compounds, and they will become better. And I work, for example, with a company. We have made compounds, and we have published that are more potent than cannabidiol itself, derivatives of cannabidiol. So chances are that companies will be working on cannabinoids and making derivatives which are suitable, more suitable to the human and more active. And probably many of these compounds, or some of these compounds, will come into medicine. The natural products, there are no patents, so the companies are not interested. But on derivatives, the companies can take patents, and they are interested because they can sell the derivatives of the plant constituents. There we are.
So patent is the key factor of company's motivation.
Well, yeah. Well, I'm not a company. I mean, I work in the at the university, and we've worked on all these things before that. But for companies, definitely patents are, I assume, very important. But I'm not an industrialist. I'm an academic researcher.
Yeah, thank you, sir. One more question. Can you tell us about EPM 301 cannabidiolic acid methyester discovery, sir?
Well, we reported the existence of cannabinoid acids a few years ago, 40 years ago, 45 years ago, just a few years ago. And, but we didn't test these compounds because the cannabinoid acids are not stable. They break down. And it is very difficult to test compounds that break down. So a few years ago, we decided to go back to these compounds, make them stable by chemical changes. We took cannabidiolic acid, made it stable, and then it was possible to test it. And we found that together with colleagues in the UK, colleagues in the US, we found that these compounds, at least some of these compounds, are excellent in lowering anxiety, they're excellent in many other fields. And so a company is developing EPM 301, and I wish them success. I hope that they will be able to make a drug out of that compound. EPM 301 is a derivative of cannabidiolic acid.
Thank you, sir. I'm really surprised about it. Now, I would like not to talk more about cannabis, talk about research. For example, how is a normal day of a research like you in your university? How is your normal day?
Well, if I understood you, now I work from home because of the corona disease. But normally I would go to work where I have a small lab, and I come up with suggestions. Other people come up with suggestions. We work on whatever we have decided. It's also a question of financing. It's not easy to get money. The universities don't give us money for research because the university doesn't have money, but we have to get money for research, and so on and so forth. So this has been going on for now 50 years, more or less the same. I've worked with many students. Many of my students became university teachers and then university professors, and many of them have also already retired because they worked with me 40 years ago. And I retired officially 20 years ago, but my university left me a lab. I used to have more labs, left me a lab, and I've been working after retirement for the last 20, 25 years.
I think university lets you work because you're a legend, sir.
Thank you, I appreciate that.
I have another question. What's the most difficult when we do international research? So I mean, when your partners, your researcher partners are in other countries, what's the most difficult?
There is no difficulty. I work with people that work in the building next to me, and I work with people that are in Sao Paulo or in San Francisco or in the US, in Canada. So there is no problem. I mean, for example, the research we're doing on addiction was started when 4 of us, myself, my colleague from the US, a colleague from Canada, and a colleague from Italy, we sat down together, we drank a lot of coffee together, we discussed the project, and we decided to go ahead. So this is a project that is being done by 4 groups together. Nobody can do that kind of research on by himself. My group is essentially a chemical one, and I understand what the others are doing, but I cannot do it. Another two groups are pharmacological groups. They understand what I am doing, but their specialty is pharmacology. And the third one is the fourth one is biochemistry. So it's a question of collaboration, and I have not seen any problems in collaboration. Worked with people in the US, in Russia, in Canada, and so on, in Japan, South America.
God. You have a global impact.
Yeah.
That's good, sir. I think that's your legacy. That's your legacy, sir.
Thank you. I appreciate that.
No, I appreciate this moment talking to you, sir. One more question.
Okay, the last one.
Yes, sir. What do you recommend to young scientists who follow your path?
Well, scientists should be looking for problems in their field. For example, if there is some indication in the popular literature, perhaps on the literature of 200 years ago, 300 years ago, that cannabis is active in a certain state. Just as an example, migraine, headaches. Queen Victoria used to import cannabis from India to help her headaches. Well, maybe there should be an animal assay, and there are animal assays, to test the cannabinoids for lowering migraine. And then if they find a compound, then start making derivatives which are more active and so on. But there are many, many other things. I mean, what do these compounds do in the body? So there is a lot to do, and I hope that one day we shall know more about them.
Oh, sir. So I want to thank you from Latin America, from Colombia, to this great opportunity, sir, to talk to you as a friend, to understand your work, and we hope to have you in Colombia if it's possible in the future, sir.
Yeah, I'm not traveling at the moment, and I'm not so young anymore. It's more difficult traveling. I'm 90 years old, so it's a little bit difficult to travel at this age. But I thank you for your interest, and I wish you success at whatever you're doing.
But don't worry, sir. Next year, I will be in Israel, so I will invite the couple.
Oh, welcome. Yeah.
Thank you, sir. Have a great day.
Same to you. Bye-bye.
Bye-bye. Bye-bye.